Hello guys, in this video I'll talk about spherical mirror. A spherical mirror is a kind of mirror that is curved like a sphere or the half of a sphere, okay, unlike a plane mirror, okay. Now when I mean mirror, like one side of the surface is reflecting and the other side is coated, is non-reflecting. Now a spherical mirror can be divided into two. We can have a converging mirror. Okay, we can have a converging mirror and we can also have a diverging mirror. Now a converging mirror is the one that converges all the rays of light that approaches it. Now for instance, if I have a converging mirror that looks like this, and again we used to have a principal axis. The principal axis is a straight line that passes through the midpoint of the mirror, and the midpoint of the mirror is always referred to as the pole, okay, or the vertex. All right, so this is the principal axis. Now if I have something of this nature, all rays all rays of light that approaches this mirror, this is the reflecting surface. The other side of this mirror, which is the place I am putting this thing on, this shows that this side is coated, that is, this other side is coated, that is, it is non-reflecting. So this is the reflecting part of the mirror. Okay, so when rays of light approaches it, it tends to converge all the rays of light that approaches it at a point that is referred to as the focal point. So this is the focal point now, F, capital letter F. Okay, so when rays of light comes probably from infinity, it tends to diverge it at that point F. Okay, so it tends to pass through it. All rays of light coming, they will always have to pass through the focal point. So we just need to use an arrow to show the direction of rays of light. Okay, now this converging mirror, it looks like a sphere, okay, and that's why it is called a spherical mirror, and it looks like the half of a sphere. It's just like I'm completing the sphere now. Okay, now it means that it should have a center. The center of this is always referred to as the center of curvature. Center C is called the center of curvature. That means from this point to this point, which is the middle of the mirror, is called the radius of curvature, capital letter R. Okay, that means from this point to this point as well is also another radius. All right, so it means that this focal length is always in the middle of the radius. That is, it is always in the middle of the vertex and the center of curvature. That means F is equal to capital letter R divided by 2. That is the radius of curvature divided by 2. Okay, because from this point to this point is small letter f, okay, which is called the focal length. So this is supposed to be the small letter f. The focal length is the radius of curvature divided by 2. All right, so the kind of images that this kind of mirror produces, when I say image, I mean the substance that is formed behind the mirror or in front of the mirror. But when I say object, I mean the substance that is put in front of the mirror. Okay, so what you put in front of the mirror, for instance, when you are standing in front of a mirror, you are the object, but the what you can see in the mirror is your image. Okay, whenever you place an object, for instance, let's say a stick image like this, probably you are standing in front of a converging mirror. The kind of images that are formed due to that object depends on the position of the object. For instance, if the object is above C, just like the way this object is now, a particular kind of images are formed, or some particular kind of images are formed. When the object is here, another kind of images are formed. That is, they have their specific characteristics. Now let's consider some positions and see the kind of images that are formed. Okay, so let me erase this. Now we are still talking about converging. Okay, now let's consider the different scenarios that we can have. So let's say you place an object. Okay, now this is the quoted side. The mirror is curved inward like a cave. Okay, that's why it is called concave. Now let's say you place, let's choose our focal point, this F, and this of course the capital letter C, which is the center of curvature. Now let's consider a position. Let's say you place an object above this, the center of curvature. Let's say you place an object right here. That means from this point to this point is object distance u. Okay, that is the distance of the object. Now rays of light will approach it in this case, and it will go like this. Okay, it will always have to pass through the focal point, isn't it? And then it will move like this. So I have something of this nature. All right, now let's say it's the rays of light also passes through the center of curvature. As it passes through it and then it touches this, that means as it moves like this, it will also be reflected back in this way. All right, so it just have to pass through the center of curvature where the rays of light intersect. That is where images are always formed. Okay, images are always formed where the rays of light intersect. Now this kind of image will face down. Okay, this kind of image, it will face, it will be inverted. And anytime images are formed below anytime images are formed below the principal axis, it is always inverted. Inverted means upside down. But anytime images are formed on the principal axis, it is always upright. Okay, upright or erect, they are the same. It means it is up, it is facing up, just like it should be, just like the object. But when it is upside down, that means the object is facing up and then the image is facing down. Do you understand now? Okay, so what do you notice about the characteristics of the image that is formed? Number one, it is diminished, that is, it becomes smaller. Okay, also it is inverted. It is inverted because it becomes upside down, that is, it is formed below the optical axis. Okay, and the third one, it is real. Why is it real? It is real because it is formed in front of the reflecting surface. Okay, it is not formed behind the mirror. Let's say you place the object on the center of curvature itself, center of curvature F. Okay, if you place the object on the center of curvature, what will happen is that the rays of light will pass through, will move towards the surface, and then of course it will go like this. Okay, and we'll also have something of this nature. We'll also have it pass through this, and then it will move this way, isn't it? So this is the point where it touches each other, so the image will be formed right there. That means images that are put on the center of curvature, objects that are positioned on the center of curvature, will form images on the same center of curvature, but it will be inverted. Do you understand now? So one, it will be real because it is in front of the mirror. Two, it will be inverted. Okay, three, it will be of the same size. Four, it will be of the same distance, isn't it? It will be of the same distance. Okay, because if this is object distance u, it will still be equal to v, which is the image distance. Okay, so let's see another scenario. Now you need to know this thing, you need to understand these explanations very very well, because this explanation will help you to solve a lot of calculation problems. Okay, a lot of problems that has to do with calculation. If you don't understand these things, you get to solve problems that deals with calculation in a wrong way. Okay, now let us consider putting the object between the center of curvature between the center of curvature C and the principal axis. Okay, center of curvature C and the focal point. So let's have the object right here in the middle. So that means rays of light coming from this point approaching the reflecting surface will have to pass through the focal point. Okay, okay, now it will also have to go like this, since it will always have to pass through the center of curvature. So let me just have my center of curvature right here. So it will move and then it will eventually touch the other ray. So wherever they touch, that's where the image will be formed. Okay, so that means images, the kind of image that will be formed will be right here. That means it is inverted, but you will notice that it is also enlarged, and it is always formed beyond C. So number one, it is real. When an image is real, we give it, when an image is real, we give it positive image distance V. Okay, but when it is virtual, we give it negative image distance. All right, so this is real, and two, it is inverted. You just need to understand the different scenarios. Okay, and it is magnified. You will notice that this is bigger than this. It will always form bigger ones. Okay, so it becomes bigger, so it is magnified, and it is always formed beyond C. Beyond C. C is the center of curvature. Now let's consider the other aspects. So when I place an object at exactly the focal point F, okay, this is the focal point F. If I place an object right there, it will move like this, and then it will always have to pass through the focal point. Also, if it goes like this, just because it will want to pass through the center of curvature, then it will move in this direction. So it tends to move straight down like that. So the two rays of light won't have to won't it will tend to form a parallel rays of light, that they won't have to meet each other, and if they do not meet, images will not be formed. So one of the characteristics of these is that one, no image is formed. No image is formed. But another text may say that the images are formed at infinity. Okay, that means they are formed at a point that is very very far, that we cannot show. Okay, but to be exact, no images are formed. Or when you have a question that talks about converging mirror where no images are formed, you know that the object is placed at exactly the focal point. And when another question says the images are formed at infinity, you know that the object is placed on the focal point. Now let's consider the last position, that means beyond F. Okay, when an object is placed beyond F. So let's say this is the F now. If I place an object right here, okay, Now what will happen to this object? The object will approach it like this. We approach the surface. We normally do this. We normally place an object very very close to the mirror. For instance, when you are trying to do a makeup, let's show the rays, the direction of the rays. So I'll have it move in this direction, and it will be reflected so that it will pass through the focal point. Okay, now if it passes through the focal point, we normally do this when we want the image to be magnified. So we move very very close to the mirror. So, and the reason it is magnified is because when we do that, rays of light, the reflected ray that actually moved in this direction, okay, the reflected ray, okay, this is the focal point. Okay, oh, let me just do it accurately. Let's say I have this now. So when rays of light move in this direction, it will be reflected in this direction. All right, so I will now have a virtual image. Okay, this virtual rays of light is due to this reflected ray. Do you understand now? So it's like I have something of this nature. The mirror is like this, and because it is reflected like this, we have a virtual rays of light that is formed. So the image will be formed behind. Okay, now let's say that I also check it at this point too, so that it will pass through the center of curvature C. That means it will also have to go like this. Okay, so I will have a virtual, and they will meet each other at a particular point. Now the point where they meet is where the image will be formed. So whenever you move very very close to a converging mirror, or whenever you place an object very very close to the converging mirror, such that the object distance is smaller than the focal length, this is what will happen. The image will be one, it will be magnified. So we normally do that when we want a magnified image. Two, but it will be virtual. It is virtual because it is formed behind the mirror. Okay, and then what can we also say about it? It is not inverted. When an image is not inverted, it means the image is erect, or the image is upright. Okay, so when we talk about upright image and we are dealing with converging mirror, so think of a virtual image, because the virtual image is formed when the virtual image is formed when the image is upright. Okay, so sometimes when the question says an image is upright, you know that probably it is virtual. When an image is upright, probably the image distance will of course be negative. So because this image is virtual now, it will have a negative image distance. A negative image distance simply because it is formed behind the mirror. Okay, and it will have a positive object distance, which is u. Okay, another thing is that you will notice that this is the only scenario where a converging mirror forms an erect image or an upright image. Do you understand now? And it occurs when you place the object above the focal point. So, and it is because the image will be formed behind the mirror, so the image distance will be negative. Now let's quickly talk about convex mirror or a diverging mirror. Now let's talk about a convex mirror. A convex mirror is also referred to as a diverging mirror, and the reason is because it diverges every incoming rays of light that approaches it. So for instance, let's have something of this nature. It is curved outwards, okay, like the back of a sphere. That means the inside is coated, isn't it? Now that means this is the pole or the vertex. This is the principal axis or the optical axis. All right, so Now, what you just need to know about this convex lens is very, very simple. Now, because this thing is curved outwards, of course, I told you that it looks like a spherical mirror, or a curved mirror is like a sphere, which the center is referred to as the center of curvature. And from this point to this point is the radius of that particular curvature. Now, what I need you to note is that, okay, before I say that, the midpoint of that radius of curvature is the focal point, and focal point is the point where all rays of light converges or diverges. Okay, that means from this point to this point is small letter f, which is the focal length. When rays of light approaches the surface, as in this direction, it will have not it won't go in this direction. It doesn't make sense. It will only have to go in this direction, isn't it? Now, if it goes in this direction, that means I can extend the rays to have a virtual, that is not real, a virtual rays. Do you understand now? So let's say I place an image at this point. Okay, let's say I place an image at this point and the rays move in this direction, and it's diverged that particular rays. I will have a virtual ray in this direction. That means the image will be formed in this point, at this point, around this point. So it is, we will always have to say that a convex mirror has a virtual focal point, because this point f, it looks like the rays of light appear to diverge at this point. If you look at it very well, it looks like this particular ray of light that I label L, it looks like this particular rays of light is actually diverging from this focal point. Meanwhile, it is not. It is a virtual focal point. That means it is a kind of focal point that it is not real. That means lights are not really diverging or converging at that point. They just appear to diverge at that point. So if I have another ray of light now, let's say another ray of light in this manner, moving in this direction, it will be reflected this way. It will have a virtual ray going through the focal point. So for a convex mirror, the focal point is virtual. That means the focal length f. So in a calculation, when you hear focal length, you know that if it is for a convex lens, it will be negative, but if it is for a concave, it will be positive. So it has a negative focal length. It also has a negative image distance, and the reason is because, let's say I have an image of this nature, and then this is my axis. If I place an image right here, and of course this is the focal point, that means this is the center of curvature. So if an image move in this direction, of course it will be diverged, and we have something of this nature, isn't it? Now the image will be formed around this point. The image will be formed around this point. Okay, the image is always formed around this point. That means it will always have a negative image distance. Okay, it will always have a negative image distance. Anything that is formed after the mirror is negative, so it will always have a negative image distance. So the image distance for a convex mirror, it is what? Negative. Do you understand now? Okay. And another thing that you notice is that the image that is formed, is it real or virtual? Just ask yourself, pause this video and answer that question. The image will be virtual because it is not formed by a, let's say, a real ray. It is formed by a ray of light that is dotted. Do you understand? When an image is formed by dotted rays of light, it is virtual. Do you understand now? It is virtual. So this kind of image that is formed is virtual behind the mirror. So it is virtual. So virtual image is formed. So these are the characteristics of the image. And two, if you look at it very well, you will see that it is upright. or it is erect. Okay, if you look at it very well, you will see that it is smaller. It will always be smaller than the object because it actually appear to be under the diverging, so it will appear smaller, so it is diminished. So sometimes I use this acronym VDVED. Okay, but we couldn't use an acronym for that of a concave because it doesn't form one kind one it has a lot of characteristics. The images that are formed possesses different characteristics. Unlike a convex mirror, this is the only, no matter where you place the, no matter the position of the object, it the characteristics of the image that will be produced will be virtual, erect, and diminished. Just one characteristic, just these three characteristics. Okay, the only thing that will happen is that the more you take it closer to the mirror, the more it is enlarged, but it will never the size of the image will never be more than the size of the object. Okay, so it is still diminished. So whenever the image has a smaller size than the object, it is diminished. Okay, now let's solve some calculations. An object is placed along the principal axis of a converging mirror of radius of curvature. Now, these are the parameters we need to take note of. Radius of curvature, a converging mirror. So immediately I hear converging mirror, I know some of the characteristics of a converging mirror. Okay, radius of curvature R. So we are solving the first one. So radius of curvature R is 30 centimeter. Another one that we have, such a real image. Okay, if the image is real, it means the image distance is positive. Okay, that means I will have a positive image distance. Now they said the image distance is 3 times its size. That is, the image is 3 times the size of the object. That is, such that real image of the object is 3 times its size. What you're trying to say is that the image that is formed is 3 times the size of the object. Okay, now there is a quantity that is called magnification. Magnification talks about the change in the size of the image that is formed due to the object, and the formula for magnification is given as image height, that is the height of the image height upon the object height, and it is, or image distance upon the image height upon, or the image size upon the object size. So I can also have image distance upon the object distance. I know that another text may put negative sign here or positive sign and saying some other characteristics and a lot of things, I know, but I will be using this formula, and then I don't want to go with that method so that I will not confuse you with signs, because when some people go with that signs, with that method, they eventually get it wrong. Do you understand now? So let's go with this, you will understand. So magnification M is equal to image height, that is height of the image, or the height of the, over the height of the object, which is equal to the image distance upon the object distance. In this video, V is my image distance and U is my object distance. HI is my image height, H naught is my object height. Okay, now the question says that the real image of the object is 3 times the size of the object. That means I can say the image height is equal to 3 times the height of the object. Okay, that's what it means. Or the image size is equal to 3 times the size of the object. Do you understand now? It means that HI upon H naught is equal to 3, isn't it? That means I can substitute it right here, 3. So it implies that v, which is the image distance, is 3 multiplied by u. All right. Now, what else do we have? The question says, where should the object be placed? That means what we need in the first question is the object distance u. Okay. Now, the mirror formula, the most important formula in this topic is 1 over f, which is equal to 1 over v plus 1 over u, where f is the focal length and v is the image distance and u is the object distance. Or I can also have 2 over r. The reason is because r is the radius of curvature, isn't it? And whenever I divide it by 2, it gives me the focal length, small letter f. Okay, so 1 over f is the same thing as 2 over r from this, isn't it? That means I can have, okay, I can go ahead, right? So with my formula, that's 1 over f. Instead of 1 over f, I'll use 2 over r, where r is 30. We don't have anything that is negative from the question, from the characteristics of the quantities that we have in the question. Then I'll have 1 over u plus 1 over v, and v of course is equal to 3u, so I'll have 3u right here. So if I find the LCM, I'll have 3u, then u in this, that's 3 plus 1, which of course is 4 upon 3u. So if I do this appropriately, I should have 2 upon 30 to be equal to 4 upon 3u. If I do something of this nature, I will have 6u to be equal to 4 times 30, isn't it? If I divide both sides by 6, okay, I'll have something of this nature. And of course 6 in 30 is 5, so 5 times 4 is 20. That means u is equal to 20 centimeter. The image distance is 20 centimeter. Do you understand now? Now let's do this question 2. Where should the object be placed if virtual image? And of course, you know the implication of virtual image, isn't it? When we have a virtual image, it means that the image distance is negative. Okay, because a virtual image is formed, or an erect image or a upright image is formed for a converging mirror when it is behind the mirror, isn't it? When it is behind the mirror, so the image distance will be negative since it is behind the mirror, so v has to be negative, isn't it? But we don't get to apply this sign at the beginning. We apply it when we have the formula. Okay, virtual image of similar magnification. That means for question 2, this magnification is still valid. Now let's do that. I'll have 2 upon r, my r is still 30 centimeters, equal to 1 over u, object distance is always positive, over 1 over v. But now my v is negative, so I just need to have minus 3u. Okay, please don't make mistake right here, minus 3u. So I just need to find the LCM. Of course, it is the same thing as 1 over u minus 1 over 3u. So I have my 3u, which is 3 minus 1. And of course, that's 2 upon 3u, which is the same thing as 2 over 30. So if you do this correctly, that's 2 over 30 equals to 2 over 3u, which means that 2 can actually cancel out 2 here, 3 here, and this is 10. That means I have 1 upon 10 to be equal to 1 upon u. So it simply means that u, the image distance, is 10 centimeter. So if I want the image to be virtual, I need to put the object at the 10 centimeter mark. If you look at it very well, you will see that this object distance is lower, is smaller than the focal length. The focal length will be 15 since f equals to r over 2. That's 30 divided by 2, which is 15. You can see that means if I want it to be virtual, I need to place it beyond f, and of course that's true. So this is the F, which is 15 centimeter, and we got the object distance to be 10 centimeter. That means they place the object above the focal point, and of course I have drawn it for you. It will be like this, isn't it? Isn't it? So the image is formed right there. So it is magnified, but it is virtual. All right, so that's just a proof of that we have drawn before. Now let's consider another example. Please stay with me, you will love this video. Question 2. An object 3 centimeter high. So this is the height of the object. Okay, so I'll say object height is equal to 3 centimeter, is placed 5 centimeter away from the pole of a concave spherical mirror. You know, a pole is the midpoint of the mirror. Okay, that means 5.0 is the object distance from the mirror. So I can have u, which is the object distance, is equal to 5 centimeter. All right, now the spherical mirror has a radius of curvature of 25 centimeter. All right, so I can have capital letter R to be equal to 25 centimeter. All right, the position, orientation, and size of the image are what? So we get to find the position of the image, that's V, that's the image distance, and then the orientation. Orientation means whether it is upright or inverted. Okay, and the size, that is, we get to find the image height. Okay, now the first thing we need to find is the image distance, because even if we were to find the image height, we will need to use the formula of magnification, which is image height upon object height, and that's supposed to be equal to the image distance upon the object distance. So we already have the image height, which is 3. We have the object distance, which is 5. So we have two unknown. So we need to find one of the unknowns using this formula, 2 over r, which is equal to 1 over u plus 1 over v. Okay, so we already have r, we have u. You know, this formula is the same thing as 1 over f. Okay, the reason is because f is equals to r over 2. Okay, I explained that vividly. So 2 over r, our r is 25 centimeter, and then u is equal to 5 centimeter plus v. All right, so I can have something of this nature: 2 over 25 minus 1 over 5, which is equal to 1 over v. All right, so 2 over 25 minus 1 over 5 is supposed to be equal to minus 3 over 25, which is equal to 1 over v. As a result, by doing something of this nature, I'll have minus 3v, which is equal to 25, which means that v is equals to minus 25 upon 3, and that's supposed to be equal to negative 8.33 centimeter. So that shows, since I have a negative image distance, it shows that the image is virtual. Okay, it's virtual, and it's true that it is virtual, because if the image distance is 8.3, no, if the object distance is 5 and the radius of curvature or the focal length, that's supposed to be 25 divided by 2, that's about 12.5, okay, centimeter. And anytime the image distance is less than the focal length, that means the object is kind of placed, the object is placed, you know, around here. So this is the focal length, and then this is the mirror, and of course it will produce an enlarged image. Okay, it will produce an enlarged image, isn't it? And of course, just like what I drew that other time, so that's the way it is. So it has to be negative. The image will be formed behind the mirror, so it is true that it will be virtual. Now let's find the orientation. Let's know the orientation is what we have seen right here. It is erect. So because we know the characteristics, when the image is virtual, we know that virtual images are only formed on a concave mirror, that when the image is upright, and we can only have that when the object distance is above or is below the is less than the focal length. Okay, so if the focal length is 12.5, the object's distance is 5. So that means we have it very very close to this mirror. So and as a result, it will produce an enlarged image, but it will be upright or it will be erect. So that's it. Now let's find the other one, the size. The size. So since I know magnification is image height, I'm using this formula now. The image height upon image height, we don't have that, and that's what we're looking for. Upon the object height, which is 3 centimeter, is equal to the image distance v. V is 8.33. Notice that it is not minus 8 points. Okay, notice that it is not, it is just 8.33. Negative sign shows that the image is virtual. Okay, so u is what? The object distance, 5. Another text may use the negative sign, but I chose not to do that in this video so as not to confuse you. Do you understand now? It is very correct this way. Do you understand now? Just use it like that. Okay, and understand the scenarios of the different positions of the object and the different characteristics of the image that will be formed correspondingly. Okay, so I'll have the image height to be equal to 3 times 8.33 upon 5, and that means the image height will be equal to 4.99, which is approximately 5 centimeter. All right, so we know that it is virtual because of the negative sign, and if it is virtual, it is upright because we understood the scenario. This is it here. Okay, and the image height is 5 centimeters. So option A should be good. The position is supposed to be it is option C. The position is 8.33. The image is upright, and the distance and the image size is 5 centimeters. So I'll go with this. A concave mirror of focal length 10 centimeter forms a real image with magnification m, which is equal to 7.5. That means the ratio of the image height to the object height, which is equal to the absolute value of the image distance upon the absolute value of the object distance. Okay, now calculate the image distance, which is v. Okay, that means I have the image height, that means v is equal to, that means v over u is equal to 0.5, isn't it? Which means that v is equal to 0.5 u, right? The focal length of f is given by the question is 10 centimeter. Okay, and it forms a real image. If it is a real image, that means the image distance will be positive. So I don't need to include any other sign, just put positive. This is the magnification and the image distance. So I can use 1 over f, which is equal to 1 over v plus 1 over u. So 1 over f is 10, v is v is 0.5 u, okay, plus 1 upon u. So if I find the LCM of this, I should have 0.5 u. So I'll have 1 plus 0.5, which is equal to 1.5 upon 0.5 u, and that means it is equal to 1 over 10. So that means I have 1 over 10 to be equal to 1.5 upon 0.5 u. So if I cross multiply, I'll have 0.5 u to be equal to 1.5 times 10, which is 15. That means u is equal to 15 upon 0.5, which is equal to 30 centimeter. If u is 30, v will be equal to 0.5 multiplied by u, which is what? 30. Recall from this list, from that relationship, that means the image distance v is equal to 15 centimeter, and that's why it is real. So it forms a real image. It is real because v is even greater than, u, the u is very greater than the focal length. It's even greater than the radius of curvature. The radius of curvature in this case will be 20. So that means the object is placed beyond the center of curvature. Beyond the center of curvature. Okay, so this 30, from this place to this place is 30, and from the center of curvature, since the radius of curvature is 10, that means center of curvature r will be equal to 20. That's 10 times 2. So that's why the image is real. So it is very correct. Now let's talk about another example. An object is located 30 millimeter from a converging mirror. That's of course a concave mirror. That means the image object distance is 30 millimeter with the radius of curvature of 10 millimeter. If the object is 4 millimeter tall, that means the image height is 4 millimeter tall. How tall is the object is 4 millimeter tall. Then the question is how tall is the image? Okay, so I have 2 over r, which is equal to 1 over v plus 1 over u. I don't have, okay, I have this. So radius of curvature is 10, which is equal to 1 over v plus 1 over u. U is 30. Why I want to find my v is simply because I will use the magnification formula straight away, which is the image height upon the object height. That's v over u. So I know the u, I know the object. If I know v, I can find my image height, which is simply the question. Okay, please don't be confused about this formula for magnification. That's the way it is. Okay, now there are different ways to find solution to problems on mirrors. Okay, so this is just one of the ways, and I think it's one of the simplest ways. Okay, so I can have 2 upon 10 minus 1 upon 30, which is equal to 1 over v. So I have 2 over 10, and then it means if you find the LCM, that's supposed to be 30. That's supposed to be 6 minus 1, which is equal to 1 over v, and that implies that I'll have 5 over 30, which is equal to 1 over v, which implies that I'll have 1 over 6, which is equal to 1 over v, which means that v is equal to 6 millimeter. So the image distance is 6 millimeter. That means the magnification m, which is image height is the question, upon the object height, which is 4, is equal to image distance 6 upon the object distance, which is 30. So I have the image height to be equal to 6 times 4 upon 30. That's equal to 0.8 millimeter. So it's as simple as that. An object 12 centimeter long is object height, that's h naught, to be equal to 12 centimeter, and then the question also gave us the focal length of 40 centimeter. An object 12 centimeter long, so that's the object height. Okay, so now let's see if we can find. We need to know that when an object is placed at the center of curvature, it will have the image height will be equal to the object height, and also the image distance will be equal to the object distance. Okay, I have explained that already. When it is placed at the center of curvature, this is the focal length, this is the object. If it moves like this, the rays must pass through 2 points. Okay, 2 points. So but for when an object is on the center of curvature, it will only be able to pass through one point, which is the focal point. If it were to be other point, it will pass through the focal point and the center of curvature. So but now you just need to pass through this, so it will move like this. So I didn't draw it very well, it's not up to scale. It's supposed to fall under the center of curvature and it will be inverted. Okay, so that means it is equal to the object height. Okay, so that means the magnification m is equal to image height, which is 12, upon the object height, which is 12. They will be the same, equal to v over u, isn't it? That means v is also equal to u. It's true. Okay, it's true. So we can find our image distance, which is 1 over 40 equals to 1 over v plus 1 over v, because u is the same thing as v. Okay, so by LCM, v can be the subject of the formula, so I have 2 right here. So it means that 1 over 40 is equal to 2v. That means v is equal to 2f. Okay, that's 2 times 40. V is equal to 80 centimeter. And it's true, because if the radius of curvature, if the focal length is 40, then this place will also be 40. That's 40 times 2, which is 80, which gives the center of curvature. That will be the image distance. Let's solve the next problem. The image of an object in a convex mirror is 2 centimeter from the mirror. So V is equal to 2 centimeter from the mirror. If the mirror has a radius, that means the image distance, okay, the image of an object in a convex mirror is 2 centimeter from the mirror. That means the image distance is 2 centimeter and the radius of curvature r is 12 centimeter. Find the object position, which is u. Oh, very simple, but we need to know that a convex mirror, characteristics of a convex mirror, the r is negative, that is the radius of curvature. Don't forget, it has the radius of curvature, the focal point, all on the other sides. So if this is the focal point, this is the radius of curvature, and this is the position where the object will be placed. So it diverges, isn't it? And then the focal point is negative, the radius of curvature is negative. Okay, and the image distance will also be negative. The image is always formed within the focal point. Okay, so those are the characteristics. So but I won't apply the signs now. I apply it only when I have the formulas ready. So what we're looking for is the image object distance, so we can apply the sign now. -1 is the same thing as what? 2 over r, isn't it? So I can say that 2 upon, but r will be negative, isn't it? And then I will have 1 over v. V will also be negative. Apply the sign convention. Apply the sign to only the parameters that are known. Okay, we know v when we know r, so we applied the signs. Okay, so 2 over minus r, that's 12, and is equal to 1 over minus v, that's 2, plus 1 over u. So I'll have 1 over 6, that is 2 divided by 12 is 1 over 6, plus 1 over 2, that is, if I take 1 over 2 to the other side of the equation, that's supposed to be equal to 1 over u, isn't it? Minus 1 over 6 plus 1 over 2, that's supposed to be, okay, if I do it correctly, you can undo that. That's supposed to be 3 centimeters. So the image distance is 3 centimeters. It's not part of the option, so I create another option for it. That's 3 centimeters. Very, very correct. Okay, how far away from a concave mirror of 40 centimeter focal length should a real image 30 millimeter long be located in order that its image be 8 millimeter long? How far away from a concave mirror of 40 centimeter focal length. So the focal length is 40 centimeter and it's positive since it's a concave mirror. How far away from a concave mirror of this focal length should a real object 30 millimeter long, that is the object height is 30 millimeter long, but I'm still talking about how far away, okay, should a real object, so we are talking about the object distance now, be located, okay, in order, so the object distance, how far away should the real object be located in order that its image be 8 millimeter long. That means the image height should be 8 millimeter long. Okay, that becomes very simple because magnification is image height, which is 8 millimeter, upon the object height, which is 30 millimeter. Okay, millimeter now, since the focal length is not in millimeter, so we can't solve everything. So but millimeter should cancel out millimeter, so we have the image distance upon the object distance. We don't have the image distance, but now I will have something of this nature. That means v will be equal to, by cross multiplying, that means 30v is equal to 8u, which means that v is equal to 8u upon 30. Now remember our formula, 1 over f is equal to 1 over v plus 1 over u. No sign convention because focal length is positive, image distance is positive, and u is positive, so 1 over f is 40, and v is 8u upon 30, 8u upon 30 plus 1 over u. If I do this correctly, I should have 30 upon 8u plus 1 over u. So if you find the LCM, that's supposed to be 8u, and then I'll have 30 plus 8, which is equal to 38 upon 8u. That means 1 over 40 is equal to 38 over 8u, isn't it? That means u is equal to 40 times 38 upon 8, isn't it? If you cross multiply, that means u is equal to 190 in centimeters. Okay, if you press that on your calculator. A concave mirror has a radius of curvature of 120 centimeter. How far from the mirror should one's face be so that the image is erect and twice the size of the actual face? Is the image real or virtual? A concave mirror, okay, that means the radius of curvature is 120 centimeter and is positive since we are dealing with a concave mirror. How far from the mirror should one's face? One's face is the object, okay, one's face be so that the image is erect. So the question is about the object distance. How far from the mirror should one's face? The face is the object that you place in front of the mirror. So how far is the object so that the image will be erect? The only time an image will be erect and it will be twice the size, that is magnified, is when the object is placed, when u is less than the focal length, when the object is placed somewhere here, okay, don't forget, somewhere here, that is when the image will be erect. Every other scenario, the image is always inverted. Don't forget the opposite of, if an object is not inverted, it will be erect or it will be upright. So that means the image distance, the image is supposed to be, of course the image will be virtual. We know it will be virtual by the understanding of this scenario, but we'll find out. Okay, now let's do this. A concave mirror has a radius of curvature of this. How far from the mirror should one's face be so that the image is erect and twice the size of the actual face, so that I will now have something of this nature. Image is twice the size of the actual face. That means the image height is two times the object height. That means the image height upon the object height is equal to 2, which is the same thing as v over u. That means v is equal to 2u, isn't it? So I can have my formula 1 over f, which is equal to 1 over v plus 1 over u. But I'm dealing with f, and f is r over 2, so it's the same thing as 2 upon r, because we are dealing with 1 over f, the inverse. So I'm going to use this formula. Now, if you look at the formula very well, 1 over v is supposed to be 2u. Okay, let me write the formula applying this convention, the signs. The v will be negative, and then I will have my u is always positive, and then r will be positive, isn't it? V is negative because the image that will be produced when in a concave mirror, for a concave mirror to produce an image that will be erect or upright, it means that the image must be formed outside of the mirror, of the concave mirror, okay, of the concave mirror, and it will mean that the image is virtual. If the image is virtual, we apply a negative sign right here. Do you understand now? So because that's the only scenario when the image of a concave mirror is erect or upright, and of course it will also be magnified. We talked about that in the first 20 minutes of the video. So I have 1 over v is 2u, so negative plus 1 upon u. That's why if you don't understand the theoretical aspect, it will be very difficult. R is supposed to be 120, so I just need to write 120. So but u, we don't have u, right? So we can find the LCM and apply some other things. Okay, so I'll have something of this nature. I can have my negative 2u right here, so that this will be 1, then this will be negative 2, which is equal to 2 upon 120, so that I'll have minus 1 upon minus 2u is supposed to be equal to 2 over 120. So the negative sign cancels out, so that I'll have 1 over 2u to be equal to 2 upon 120, which is the same thing as 120 equals to 4u. That means u is equal to 120 upon 4, which is equal to 30 centimeter. Okay, that means the object distance is 30 centimeter, and that's the question: how far from the mirror should one's face be so that the image will be erect and twice the size of the actual face? The object must be placed at the 30 centimeter mark. Okay, now the question says, is the image real or virtual? The image is always virtual whenever, this is it, whenever the object distance is less than the focal length. That is, whenever we place the image in a position such as this. Okay, now this is it. See, from this point to this point, I explained that that is the radius of the curvature, and is given as 120, which means that from this point to this point, which is the half of the radius of curvature, is 60 centimeter. So the object distance is 30 centimeter. That means from this point to this point is 30 centimeter. And anytime we have the object between the focal point and the vertex or the pole, it used to produce an erect image. Okay, and erect means it is upright, just like this. It is not upside down, and then it will be virtual because it is behind the mirror. Every other image is formed by concave mirror are formed in front of the mirror, and they are always real, and most of the time they are always inverted, and sometimes diminished and sometimes magnified. So that's it. The image of an object in a convex mirror is 2 centimeters from the mirror. if the mirror has a radius of 12 centimeter, okay, the image of an object in a convex mirror, that means is 2 centimeter, that means the image distance is 2 centimeter. If the mirror has a radius of 12 centimeter, find the object's position. Okay, but don't forget it's a convex mirror, and a convex mirror, we have a negative focal length. It also have a negative radius of curvature, isn't it? All right, now let's apply, we are going to use this, right? Now let's apply the signs to the parameters that we know. Okay, now we know v, right? That's negative v plus 1 over u. We don't know u, so we leave it as that. Then 2 over r, we know r is given as 12. This is also given, so I apply the sign to it immediately. That's negative r. Okay, so that's 1 over minus 2 plus 1 over u equal to 2 upon minus 12. Okay, you should also note that the focal length is negative 2. Sometimes if you have a question that the mirror used is not specified, to know the kind of mirror that is used, you can simply find the focal length. If the focal length is positive, it is concave. If the focal length is negative, it is convex. Okay, or if r is positive or r, so these two parameters can help you know the kind of mirror you are using if the mirror is not specified. But this kind of question, we know the mirror we are working with. Okay, so I will have 1 over u to be equal to 2 upon minus 12, and then plus 1 over 2, that is by taking minus 1 over 2 to the other side of the equation. So if you do this correctly on your calculator, you should have 1 over 3, which means that the object distance is equal to 3 centimeter, and is positive, which shows that the object is real. Of course, the object will be real. Okay, and then it produces a virtual image since it passes through a convex mirror of negative focal length, and of course a virtual image will be produced, a negative radius of curvature. Thank you for watching this video. Share it with your friends, subscribe to this channel. More videos are coming your way. Thank you.